Okay, so we're going to talk about periodic table trends. So these were your notes, which, you're going to remember to put your name. And just as a quick note up here, it says trends are predictable changes, and the way you have to know them is going across a period like this from left to right, because that's in order of atomic number, or going down a group from top to bottom, because again, that is going in order of atomic number. There is no memorization necessary. The values are found in table S, okay? So what is atomic radius? It's the size of an atom. It's found using half of bond radius. So here is an atom, that's the nucleus in the center. The radius is the distance like that, like it is in a circle in general. But because atoms are so small, we have to measure bond radius. So that's nucleus to nucleus and take half of it. Kind of don't really need to remember that. Just know that atomic radius is size of the atom, okay? Now, I already plugged numbers in here going down group 2 and across period 2, okay? But where did I get those numbers, okay? So looking at the periodic table does not tell me the numbers. I have to go to table S. And then if you look, period 2 starts with lithium. So I went lithium, and we're looking at atomic radius, which is all the way over here, PM, picometers, picometers. And we start with lithium, then we go to beryllium, then to boron. Okay, that's where I got those numbers. And then I did the same thing to get the numbers for going down the group. Okay, so what you have to do for this assignment is put arrows on this periodic table to show the trend. Okay, so see the question at the bottom, right? So I'm going to do an arrow. So I'm going to go across a period. I'm going to look what is happening to those numbers for atomic radius. Well, if they're too hard to read, you can look them up on the periodic table. But what is happening is it is decreasing. It decreases. So atomic radius decreases going across a period. Now let's talk about why. Well, there are two main factors that affect force of attraction. There's nuclear charge and distance, okay? And the distance that we talk about is between the nucleus and valence electrons. Okay, so we're talking about distance between the nucleus and valence electrons. So these are the two factors. So what is changing as we go across a period? Well, in period 2, this element has 2 energy levels. This one 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 has 2 energy levels. So since we're not adding energy levels, distance is less of a factor. Okay, because in general, we're just adding to the same energy level. We're adding protons as we go across. We are adding electrons, but because we're adding protons to the nucleus, the protons are going to be pulling each electron tighter. So that is nuclear charge. Nuclear charge means as we go across the period, we add a proton to the nucleus every time we increase an atomic number. So as we go from lithium, which has 3, to beryllium, which has 4, beryllium has a stronger pull, to boron, to carbon, to nitrogen, to oxygen, and so on, as we go across every period, okay? So why would the size decrease? Because we continue to add protons, so that nucleus gets more positive, which means the force of attraction is a little greater every time we do it, which means it pulls the electrons tighter and decreases the size. So why does the size of the atom decrease as we go across a period? Because the nuclear charge increases and the electrons are pulled tighter. So size decreases. All right, so that's across a period. Now talk about down a group. Well, if we go down a group and we look at these numbers for atomic radius, if you can't read them, look them up on the periodic table. So as we go down a group, what is happening? It increases. Okay. All right. So why? Well, our two factors are either nuclear charge or distance. So why would the atomic radius increase as we go down a group? Well, because in group 1, those elements have one energy level. In group 2, they have two energy levels. Group